For year 11 methods, we're going to look at question 13 of exercise 14e. So this is a question where we're given 3 points on a circle and we're trying to find an equation of it. Now, if we look carefully before we even start the question, we can see 2 points actually x-intercepts of a circle. Now great, because I know that if a circle, for whatever reason, cuts the x-axis twice, then I know that the x-coordinate of the center of the circle will be between the two x-intercepts, okay? So I know that the average between 2 and -4, so if you can go 2 minus 4 divided by 2, so I'm just simply taking the average of it, I get -1. Okay, so the x-coordinate of center is x equals -1. Okay, great. I can actually sub that in because I know the x1 of the center is -1, so we know that when we put it in an equation, that's x plus 1. We don't know the y coordinate, so I'm just going to call that a, and we don't know what the radius is, so we'll just call that r squared. Now, I'm going to use the information, like whatever information is given in the question, to find my a and r value. We've already got our x-coordinate of the center, so that's great. So we're going to have to do some simultaneous equations, okay? So let's sub in a few points. So I'm going to sub in 0, 2, okay? So when I sub in 0, 2, let's see what we get. So when x is 0, y equals 2. Okay, let's start doing stuff in our head because we don't want to spend all our time writing or working out, okay? So when I sub in 0 for x, that becomes 1 squared, so it's 1 plus y, my y is 2, minus a squared equals r squared. So that's my first equation. I call that equation 1. And I'm going to sub in another point. Let's sub in 2, 0, just because it seems nice. When I sub in 2, 0, let's see what we get. So x is 2, 2 plus 1 is 3, 3 squared is 9, plus y minus a, so y happens to be 0, so we get negative a squared, which is just a squared, equals r squared. Equation 2. Now, I need to solve these equations simultaneously. So I want to eliminate. If I subtract one from the other, I can eliminate the r squared, which is what we want, because the idea behind simultaneous equations is you want to eliminate one of the variables if you have two equations. Okay, so you're just solving for one variable. Okay, let's do that. So I'm going to go equation 2 minus equation 1. You can do either way, both are fine. I'm just choosing equation 2 minus equation 1. So 9 minus 1 is 8 plus a squared minus 2 minus a squared equals r squared minus r squared is 0. Okay, so let's expand and solve this. Okay, so we'll expand the brackets. When we expand the perfect squared, we get 4. 2 squared is 4, so you get -4 because there's a negative at the front. A squared becomes negative a squared, and the middle term is negative 4a, so it becomes a positive 4a equals 0. I'm going to cancel the a squareds because we've got an a squared and a minus a squared. We've got 8 minus 4 is 4 plus 4a equals 0, so we can automatically know in our head that a equals -1. Okay, now I've got my a value, so I can then sub this back into one of our original equations. Okay, so I'm going to sub it into equation 2, back into equation 2 because that's an easy one. We get 9 plus, when a is -1, -1 squared is 1 equals r squared. So r squared equals to 10. Okay, then we got our equation of a circle because we found what our r squared equals to, we found what our a equals to, and we found what our x coordinate of the center equals 2. So x plus 1 squared plus y minus, okay, a is minus 1, so that becomes a plus 1 squared equals 10. So that's your final equation for, this is the final equation for a circle that passes these 3 points. So as you can see, it's not impossible to do. You just got to know what information to start off with. And knowing something like the x coordinate of the center of the circle helps us a lot, so we don't have to solve, 3 equations, which makes it very much more complicated. Hopefully this helps.